Welcome everyone to the OpenUSD Insiders live stream. Thank you so much for joining us live. I am thrilled to bring you a very special session today, which is focused on robotics, simulation, and the journey from virtual models to real-world machines. We have a very special guest that people in the community will know right away. His nickname is LycheeAI, but his real name is Muammer Bay, coming to us from France today, I think near Paris. He's an Omniverse ambassador. We recently announced him at GTC 2025, and with good reason. He's an amazing educator, the founder of LycheeAI Hub, which is a platform dedicated to making robotics more accessible through open source tools, step-by-step tutorials. And he's just got a very strong sense and focus on community, which is just amazing. As I mentioned, he's recognized for his tutorials. Most of them are focused on Isaac Sim and Isaac Lab and OpenUSD, all of which we're going to be touching on today. He guides learners through the process of simulating and training and deploying robots like the open source SO100 ARM. His passion is helping others learn by doing, and today we'll be doing exactly that. He's going to be walking us through his latest work and what's next on his journey, including inspiration from NVIDIA's Groot and One humanoid foundation model. You can explore his work at LycheeAI-hub.com and on YouTube if you search for LycheeAI. I'll post links in the chat in just a second. But I'm also very honored to be joined by two special guests from the NVIDIA team. We have Eric Bowman, a leading voice in robotics and simulation workflows, and Michael Gassart, otherwise known as Gus, who brings deep insights into Isaac Sim and Isaac Lab and real-world implementation. Together, we're going to dive into the tools, platforms, and community efforts that are shaping the future of robotics. Excited to jump in right after these quick announcements, starting with the first one on the screen. We have this great link I'm going to be posting in the chat about how Foxconn is teaching robots to learn, train, and simulation real-world deployment. I highly recommend everybody check that out. We also have a great on-demand session, which is available for free, Reinventing Smart Manufacturing. I'm sorry, this is the Foxconn reference, Building and Deploying on AI. I'll post this link in the chat as well. And for these next couple slides, we have QR codes. We can use your phone to scan and bring the links easily to your phone or your computer. These are the Industrial AI and Digital Twin sessions that we just wrapped up at GTC 2025. And these are the Physical AI and Robotics sessions, also at GTC 2025. All this stuff is available on demand, including OpenUSD sessions. Here's this one. If you miss any links, don't worry. I will post these in the chat later on in the stream. But for now, I'm very, very honored. Let's bring up our NVIDIA guest first. So here's Eric Bowman. Hey, Eric.
Hey.
Otherwise known as Strainflow. Everyone here has a cool nickname except for myself. So you're Strainflow. We also have Gus here, and actually Eric just came up with a nice name for Gus's fan.
Oh no! Oh God! Oh,
what was it?
Oh no!
So I think that Gus's new fan base are called the Gus Bus.
Oh.
And I just can't wait. As soon as we get some calls to Gus, then I can say the Gus Bus has arrived.
I don't know if I can do the awkward seal meme hard enough.
I love it. I'm so glad to have you two especially here for our special guest, because you have obviously been engaging not only with the content he's going to be talking about, but engaging with LycheeAI himself, or Muammer, I should say. So as part of different study groups and on the Discord server as part of the live streams. So really, really glad that you guys can jump in and be part of the conversation. A special note to everybody watching, we highly encourage, as usual, to post your questions and comments and feedback into the live chat. We're going to be trying to address those in real time. Anything we don't get to, I'll try to hit towards the end, but we'll try to hit as much as we can in real time. Definitely feel free to introduce yourself in the live chat. Let us know where you're watching from. If you got any active projects regarding this content, absolutely feel free to share with the world. But without further ado, the very special guest of honor waiting in the wings. Let me press my special button here to bring him up. There he is. Muammer Bay, otherwise known as LycheeAI, ambassador for the community, just announced at GTC. Welcome. It is such an honor and privilege to have you on the live stream. This is actually a live stream I've been waiting for a long time to have, ever since we started seeing your amazing work on your YouTube channel, which is LycheeAI. I'll post a link in a second. And then not only have you been engaging with the community on the Isaac Sim and Isaac Lab channel and the study group that we have weekly meeting on the Discord server, but you've also are starting to work with other great creators and educators and put together LycheeAI Hub. which is a platform kind of consolidating all this information revolving around robotics, and especially Isaac Sim and Isaac Lab in one place, which I think is just amazing. So it's so all that and more. You also have just a fantastic way of teaching materials and presenting your information. So really happy to have you here to talk about how people would actually train a robot from scratch in simulation. And this is going to be kind of a step-by-step process. I should say to everybody, this is not going to show everything from end to end, but this is kind of like a work in progress. So he's going to show everybody how to get started, and he's going to show us in real time how he would do this. And then we'll probably continue down this conversation either on our Discord at a later date or as a future live stream. But Muammer, thank you so much for joining us.
Yeah, thank you so much for having me, and also for the kind words. I'm super excited to be here after having probably watched like a million of these live streams before. And yeah, I'm super excited to show the project and to be here.
It's great. So let me ask you, let me just to kind of give a little context on your background. How long have you been working with NVIDIA Omniverse and with robotics in general? And what inspired you to actually start, teaching some of this stuff to everybody?
Yeah, so my background, I guess, I started 1.5 years ago to actively work on Isaac Sim. I was back then working mostly with synthetic data and also some simulation and physics simulation. And around half a year ago, I wanted to really dive deep into robotics. And the whole channel, LycheeAI, and also the hub kind of started from me wanting to show my learnings and share that with the community. And I also saw like so many awesome projects, and I wanted to kind of collaborate with everyone and have a platform where I can do this. And yeah, I've already managed to have some from the community, and it's awesome. So,
so what I'm so impressed about everything you just said, but what really kind of hit a chord that I wanted to just repeat here is that you really only started working on the robotic stuff about 6 months ago. Is that what you said?
4 to 6 months. Yeah.
So that's pretty impressive, and that's pretty inspiring, I think, for everyone else who's watching this. Obviously, for some of the viewers out there, we have people who are kind of just learning about robotics. We have people who have been fooling around with it for a little while, and then we have people who actually have companies, startups, and more long-term companies that have been working on this for a while. So I think it's very inspiring for those people out there who are watching, who are just getting started, though, that your journey actually was not a crazy long length of time, and actually, and you how long ago are you a student right now?
It's a bit difficult. I kind of dropped out because I'm pursuing a career in robotic simulation, and so I'm currently on the way to drop out. But technically,
that's awesome. So you're so inspired, and you're
already flying.
Yeah, you can't wait. That's amazing. And obviously, I think one of the most amazing things with your tutorials, as people will find out over the next 50 minutes or so, is how accessible your content is and the way you explain things. So tell me a little bit more what you plan on showing off today. And actually, for context, before you start that, Eric and Gus, can you tell the audience, just so they can kind of have good perspective on what kind of questions they can throw at you specifically in the chat?
Sure.
Can you tell us a little bit about what your focus is on your at your time in NVIDIA right now?
Sure. I'm one of the initial members of Isaac Sim. I've been here since 2016. And my background is in physics, and I focus on the research part of our team. I'm one of our research scientists, so I'm interested in like the fundamental physics of cognition and how all that works, and how we can use Isaac Sim and simulation to test and examine some of these hypotheses that we have about how cognition functions that come from cognitive neuroscience in robotics. So yeah, that's where I'm coming from.
Oh, amazing. That's great perspective. And Eric, you've actually been part of the community, obviously, for a while, engaging directly with developers on our Discord server, which we'll post a link for in a few minutes. I've been actively engaged in study groups. You've actually had your own live stream series, teaching people from scratch on how to do different work with robotics, including the F110th project. jet racer. So you've got a leatherback. You've kind of been touching a lot of different projects that really have been exciting in the community. Tell everybody what your role here is and what you're focused on and why you do these types of things.
So I am a technical marketing engineer at NVIDIA, and that's a role that I have never seen that at another company. It doesn't mean that it can't be found there, but I didn't know what it was even when I started. But a technical marketing engineer is a technical person whose role is to develop content to help as many people as possible to adopt a technology. And so I'm just here to help as many people as I can get involved with robotics. And I love it because if you're working with robotics, I don't have to worry about like a specific technology or a specific software, because chances are if you're working with robotics, you're using NVIDIA technology somewhere along the way. And so if I just help people use robots, then I'm doing my job. So
that's awesome. What a great job you do. I can't thank you enough for members of the community here over and over again. How helpful it is to have your time and efforts on the Discord, especially the study group. So thank you. And I think Gus, you just went to your first study group, right? Like last week.
Yes, I believe so. Yeah, and it went well.
That's great. So again, we do have a weekly study group, which happens on our Discord server. So if you're interested in diving into Isaac Sim and Isaac Lab or robotics in general, it's a great place to come hang out. It's like a voice chat like this. You turn your webcam if you want and just tackle different questions, problems, scenarios. It's a great way to learn. We also have a great learning path that you can take at your own pace. I'll post a link for that in a few minutes as well. That's specifically focused on robotics. We have another learning path, free courses focused on OpenUSD. Some of that stuff I'm sure Muammer has used in his learning journey, and also has provided great feedback to us on that stuff. So I also have to call out. I'm looking at the chat here right now in real time, and oh my gosh, you have a lot of fans here. So here's one. Actually, I just saw Jan at GTC 2025. Really awesome to see him. Thanks for joining us. This is another great gentleman I saw at GTC 2025. Very experienced with robotics. So very cool. Happy to have you join us here. Here we go. Another nice comment. A lot of cool comments coming in from LinkedIn as well. So okay, so we're going to kind of take questions as we can. We're also going to post the links for this. So if you're watching a replay of this, or you're watching it now and you want to just grab links later, we will normally put all the links we talk about in the Discord channel we have called live stream. You'll find a thread specific on this live stream. So don't worry if you miss anything here. We'll post it there. Okay, so let's get started. So Muammer, tell me a little bit more about what your goal is and why you chose this specific type of hardware you're gonna. Did I refer to it correctly in the intro?
Yeah, that was good.
So tell me, why did you choose it?
Yeah, sure. So my goal right now is to learn more about the sim to real approach, because so far I've covered a lot of the robotic simulation part, but of course the real part is where it gets interesting. I also received a ton of requests on my YouTube and the platform or Discord about these type of projects, and I've chosen the SO100 ARM or SO ARM 100 because it's quite affordable. And I've also seen a French startup that actually lives quite close here and that I managed to have a demo with to check out the demo. And they have connected the
Can I pause you just for a second? Because you're talking about this S100 manipulator.
Yeah,
the ARM.
I didn't know what that was until like yesterday. Actually, I started to hear a little bit about it maybe a week ago. And it's kind of the new hot open source manipulator, or is that right?
Muammer, you're the one who introduced it to me. It's 3D printed, right? It's like hot off the
It's like the brand new. It's open. Sorry, it's open source. I think it's cheap.
We're too excited.
People love it.
Yeah, it's awesome. Sorry.
Let me see. I'm gonna see if I can put this on the screen so people can kind of get more context. But this is what you're talking about, right?
Exactly. Yeah. So yeah, so
there's a GitHub page for it. I'll post this link from the Robot Studio. It looks like.
Yeah. This one is also covered from Lil Robot or LE Robot, which is kind of a platform to make robotics more accessible, especially for AI. And yeah, this one, I wanted to mention that this one French startup I was talking about, Phosphor, they have managed to connect it with the ISAC root N1, which I'm also quite fascinated about. And my first goal would be to have the sim to real with ISAC Sim and ISAC Lab, and 3D print it myself, and then connect it, with ISAC Sim, and then later also train the Groot N1, the newest model. And that's kind of
Amazing.
my goal.
What
So this-
computing stack do you use with that? Are you using? Do you just plug it right into your workstation? Do you have a Jetson? Do you have an Arduino?
I believe from the videos I've seen, I haven't printed it out yet, and I don't have the hardware at the moment. But I believe from what I've seen, it's connected via USB to a laptop.
Oh, so you don't need any extra. So if you have a workstation or a laptop, you should be able to use it.
I think there would be some hardware in between to not like overvolt it, I guess. But yeah, it's
Maybe some kind of like a controller for the motor or something. I think
Well,
one thing
So let's.
this I find really exciting about this one is I've already seen videos of people getting it to do stuff. And a lot of times I see these open source robots and they look nice, but then there are no videos of people getting them to really work. But this one, I've seen people actually getting it to work, and that's nice.
Can you tell us a little bit about your goal with the ARM? What you want? Like you want to where your goal in general is to produce this teaching platform, but this specific project with the ARM, what do you want to try and achieve with it?
okay. Yeah, for now, I just wanted to pick up a cube from one place to the other.
Yep.
I like it.
Well, we actually had a suggestion for you. I'll put it in the chat just because this is from the captain from the community. So yeah, maybe one day they'll probably play nicer music than me for sure.
I think that reminds me too much of Showbiz Pizza, which I found a little scary as a kid. I don't know if people maybe that's too nuanced of a reference, but get an animatronic robot playing the piano.
That'd be amazing. So just to recap this, so this is basically design, right? That you print the parts for yourself, and or it looks like there are some also links here if you want to buy the kits. People are selling the kits. Is that, and you're planning on basically just printing this yourself?
Yeah,
Okay.
How much does the kit cost if you would buy just an out of the box kit?
You want me to click on this?
Yeah,
All right, let's do
I'm
it.
curious.
Do you
Oh
dare?
God, blocked. I knew it.
I dare. You chose boldly.
I'll try. I'll look at it on my separate computer here, and I'll try to update you guys. Okay. All right. So that is.
We actually have an answer here.
Oh, you do?
$199.
Oh, there you go.
Oh, actually, $299 fully built. So
That is, Eric. You also you've been searching for a affordable robot to do with a study group, right? That everybody can
Totally.
get into. This kind of feels like it would fit that range. Not super cheap, but for a robot arm, that's pretty good.
It's cheaper than
yeah.
some
Well, I
video
mean, the
game
other one
ones.
I was looking at is. Oh, sorry. Go ahead, Gus.
I was just commenting on the price. Never mind.
Well, there's one called the Agilex Piper that's really nice. It's a professional robot, but it's certainly more capable. But it's also, I don't know, $2,000. I want to say $1,000 or $2,000. Now, is that $300 for both, or is that? Because I can see there's a leader and a follower here, and we can talk about that in a sec, what that means. But is that $300 each? Yeah. So $300 for each one. And Lychee, can you explain what a leader and a follower are?
Yeah, so I guess it's like the one will be controlled, for example, via NVR or AR headset, and you can control the robot via VR or AR, but you can also take the leader and you can move it around, and the other one, the follower, will follow the movements, and basically you can use this to teleoperate, or you can also use it to collect data for the ISAC Groot N1, for example.
Oh, and actually, Andreas is saying it's $300 for both. So that's really very affordable.
Absolutely.
Nice.
Yeah.
That's nice.
Okay, cool. All right, I'm going to take this off the screen. All right, awesome. All right, so what would be the next steps here, Muammer? How do you want to cover this?
Yeah,
I want to see what you've done so far with this arm. Like, have you gotten it into the sim? Like, does it function? Like, what does it look like?
yeah, I would love to show that. It's like what I wanted to kind of do is a walkthrough on how to import the URDF from the GitHub that you have shown just a second ago, and then load it into Isaac Sim to save it as an USD, and from there train it in Isaac Lab. This is kind of what I would like to do and showcase, and I think within 20 to 30 minutes that should be feasible.
Amazing.
Yeah.
All right, man. You have the floor.
Okay, I will share my screen.
And for everyone who's commenting in the chat, thank you so much for joining us. I love all these comments coming in. So many great people here joining us. You are all part of the show, so thanks for joining us today. Here we got, let me see if, let me know in the chat if the font size looks good here. Otherwise, I can make it a little bigger.
It looks okay to me.
Yeah. Okay.
Okay, so yeah, right now I'm inside Isaac Sim. Of course, a application available from Omniverse, and right now I have downloaded or cloned the repo that you have shown a second ago. They have the URDF file, which is a common file type for articulations inside a robot and like the setup, including the meshes. And I would like to show kind of where to start. So we want to import the URDF into Isaac Sim, and we do it by pressing import. Right now I'm already inside the correct folder for the SO100 arm under URDF. I just wanted to also quickly mention that I will do a separate tutorial for the complete walkthrough in more detail on my channel for people that are interested in more later on. But for now, I will load the URDF file. In here, we have some settings that we can specify. So, for example, I want the robot to be created in the stage instead of referencing it to be able to share it. I want to set it as a default prim. Yeah, I will not walk through all the steps here, but kind of the important ones. It will be a static base because it's not a mobile robot. And yeah, I want to, I guess this is kind of all, like these settings are not too important because we will also modify a lot in Isaac Lab. Should I maybe also explain a bit more about Isaac Lab for those?
I mean, I can, if you'd like, whichever.
Yeah, I would prefer it.
Sure. Sorry. So right now we're in Isaac Sim. Isaac Sim is like you said, it's an application from Omniverse, and this is our tool for examining the simulation, which runs all the physics and the collisions, and it makes the magic actually happen. Isaac Lab is a layer that's built on top of Isaac Sim that is used for vectorizing, which is to say copying and replicating all of these environments across the simulation. So it can be used for different forms of training. Right now it's mostly focused on reinforcement learning, but we're intending to add other types of learning as well, like imitation and so on and so forth. Yeah.
Perfect, thank you.
But I'm curious about the stiffness and damping settings for that import that you did. Did you modify any of those, or did you keep them the same?
Oh yeah, I wanted to talk about that more in detail as well. I have used the URDF settings here for the already specified settings for the stiffness and damping. I guess these are defined here, but I have realized that the URDF file has these ratios and parameters which are not loading correct. I will show that in a moment. And my assumption is that there has been a SolidWorks importer for the URDF, and as the SolidWorks is probably operating in millimeters or centimeters, and Isaac Sim is operating meters, some conversions might not be correct. So I wanted to change these afterwards.
Yeah.
Okay, so okay, I guess I wanted to show the also a very useful tool for starting. It will be under Tools, Physics, and Physics Inspector. This is a very useful tool to see if everything is correctly set up. So if I click on the robot here, which is already structured well from the URDF file. So we have the joints here and all the parts in here. If I click to actualize, we can see all the joints, and we can play around with the movement. So as you can see, the robot is not really set up well because the stiffness and dampings are kind of playing weird. And I realized that I probably have to change these parameters, and I wanted to show how to do that as well. If there are no questions in between. Okay. So what you can also do in Isaac Sim, probably a bit hard to see, but on the top right, there's a filter for physics joints. And this will show only the joints here. And when I go into the properties, I can see that the damping and stiffness are, like, first of all, very low parameters, and also the ratio is not set up correctly. When I have multiplied it by 100 or 1000, so probably the conversion between centimeters to meters or millimeters to meters, I realized that the values make a bit more sense, but still are not correctly set up, I feel like. So I just changed the parameters for the shoulder rotation, for example, and as we can see, it's already like moving smoother and like more realistic from what has been specified from the URDF. And at this point, I would also like to mention that I do not have to specify these settings here, because I will do it in Isaac Lab kind of manually inside the configuration. So I will not play around these for now, but there are still some steps that we have to do before we can work in Isaac Lab for the reinforcement learning task. Okay. Okay, so I will continue with that. So first of all, one very important step I saw and I realized is that we have to specify the articulation root. If we filter the articulation root here, we can see that it's done for the root joint, which will not work for Isaac Lab. Maybe one of you guys can tell me more about how the articulation
selecting the root joint doesn't work as the root articulation for Isaac Lab. Yeah, so the root should be a prim, not a joint. So the root articulation, I think you specify if you go to the root of the robot. So if you disable your filter, right, go to the root of your robot, and then go to add physics articulation root.
You're on the whole. You probably want to be on the base mesh.
Oh, okay. For me,
not the overall container. I mean, it'll somewhat work with the overall container, but it'll just pick one of those randomly to be your articulation root. But you want that one to be your articulation root.
That specific one? Okay. Then you want to remove. Make sure you want to remove the articulation root on. So you just got to scroll down to the physics section on that root prim. Articulation root. Yeah, there you go. Get rid of it. Kill it. Just click on the X. No, the X.
Yeah, when I have tried it before.
No, there you go. There you go.
Awesome. All right, now you can add a new one. Yeah, sorry.
You're there for a minute.
Yeah, no, I wanted to say that I've tried it before, and for me it has worked on this one. So I'm a bit afraid it will not work now if I set it like this. But
yeah, I always set it on the root prim of the robot, and I let the system identify, because what it's going to do, what the purpose of the articulation is to notify the physics engine how it needs to access the data in a again, there's a term vectorized form. So behind the scenes, there's this thing called the Tensor API, where all of this data is kept as just big giant matrices and stuff, right? The articulation root defines the tree traversal that figures out what all those shapes have to be, right? So and there's it's also there's a whole, we could do a whole stream on like getting meshes ready to be instantiable. So a lot of people, I think that I see on the forums, I see a lot of people have problems with adding their robot to Isaac Sim, and when it appears, it's just an empty transform and there's no meshes there, right? Why is that? Well, part of the reason has to do with this vectorization process, and you have to set up the asset appropriately to be able to be copied and instanced many times over the course of the simulation. And if that process isn't done properly, then you can get all kinds of weird like consequences and stuff. So sorry, I didn't mean to derail things. I was just
I want to also just point out we have a good question here. Actually, two people asked the same kind of question. I'll put this one on the screen. What are the stiffness and damping of the joints? I didn't find how they're used in the docs. And
yes.
then Kamade also, the other viewer who I mentioned earlier, who I met GTC, he asked, is there a calculus for damping and stiffness for Isaac Sim other than just play and sim?
Yeah, so what's going on here is in order to keep the sim performant, we simulate all the joints and motors as dumb as possible, right? So there isn't like an electromagnetic sim that simulates stators and stuff. What we have is we have a simple spring system, and that spring has a spring coefficient, and then there's a damping factor that determines how the spring responds to an applied force. So if you're talking about a rotational force, you're talking about like an applied torque and the damping term on that torque. So the stiffness and the damping coefficients or factors, because I'm not privy to the actual intimate details of how the simulation is done, but it's modeled off of this spring model for the joint, right? And so the stiffness determines how quickly the joint goes to the target that you're setting it. So if you have a drive position or a drive force, the stiffness tells you how quickly that's going to be applied. And then the dampening tells you how susceptible you want it to be to oscillation. Like how rigid do you want it to go to that location and then stop like hard, or do you want it to like be a more graceful like easing? And those are the parameters that determine that. There's also another parameter called the gain that has to be tuned appropriately in order to get it to match sim to sim. But again, that's a different conversation that we can have.
Well, in those stiffness and damping parameters, they don't have exact physical. They're more like simulation parameters. They're not exact simulation parameters.
Yes.
Yeah. So,
and when you do sim to real transfer, there's a whole type of domain randomization that specifically focuses on the randomization of the physical parameters of the simulation, so that the policy becomes robust enough to be able to handle the real world with parameters that are unknown, but hopefully within the bounds and range of the simulation randomization that we did.
well, and I just want to reiterate that.
Yes, it's a PID.
I was so confused by that at first. And so I just want to repeat that. So when I was getting started, I was trying to make the simulation as realistic as possible. And coming from a mechanical engineering background, it drove me nuts that those damping and stiffness parameters in the joints didn't have direct physical correlations.
Yeah, and I think Hazam.
But with AIs and training, it doesn't always have to be perfectly accurate. It's okay as long as you randomize as you're training.
Yeah, and to sorry, I can't log into the chat to be able to interact with the chat, but one of the members, Hazam Irashid, I'm so sorry if I'm mutilating your name, but I believe yes, it is a PD controller. I don't believe there is an integrated term in the controller for the joint. And Isaac Lab provides an actuator layer that gives you much more definition over how you want that joint to be actuated and how you want that simulation to take place. But I think as a default, it is just a PD drive coefficient. That's right.
Yeah. Cool.
Okay, cool. I
This
feel
is
like I'm
great.
learning a lot
I love
here.
Awesome.
So thank you for that.
Sorry.
Yeah, I guess I can maybe continue, or do you want to add
Yeah, no,
something?
please. Yeah,
Okay.
sorry.
I know, yeah, so I kind of have to look if I'm not missing a step. So yeah, the one last thing that I would have to, or that I would want to change is we see these collision meshes here, and
The green outlines, you mean?
the green
Those are the
outlines.
collision meshes, yeah.
Yeah, exactly. And I want to change it, at least for the gripper, because I want to pick up a cube. And when I tried it the first time, I realized that these are not accurate enough.
Yeah.
So
I noticed that in your import, I noticed that you chose the convex hull instead of the
Yes.
convex decomposition.
Mhm.
I was like, oh, that's interesting. But I thought, but if you did convex decomp, so maybe we should explain what these are. Like, it's really easy to see with that base part. If you all look at the green lines, you'll see that there's some space. So the green lines are the collision mesh, and the triangulate in the convex hull is, imagine if you just shrink wrapped it. So you shrink wrap around the whole thing, and so wherever you have it, wherever it dips in, there's going to be kind of some space between your collision mesh and the actual part.
Yes.
The nice thing about a convex hull is they're really cheap to calculate collisions with them. And so we like them for that reason, but they're not the most accurate. And so there's this trade-off between, well, how accurate do I want my collisions to be, and versus how quick do I want calculations to run? And I think I would do exactly what he did, which is start off with a convex hull because they're cheap, but then go to things like the gripper where you need more accurate contact and collisions, and then put a more refined mesh just on those parts.
yeah, that was exactly also what what I wanted to do when
Yeah.
I tried the URDF importer, and I chose the convex decomposition. I realized that my simulation is like way slower because it's harder to calculate, of course. And then I wanted to do exactly what you mentioned, the convex hull for the entire system, and just specifying it for the ones that are kind of needed. So I will do this under the prim for these both under collision. So we'll change that to convex decomposition. It will take a moment to load. It might take a bit longer to load. I'm
Because
sure.
we're watching. It
You know,
knows
when
we're
you're-
watching it, and then it's like, I'm going to do it wrong now.
Well, and when you're sharing your screen,
Oh.
it takes some of your computer's resources,
Oh,
and so
yeah.
everything runs slower. That's kind of a classic problem that I have. But while that's loading, I just want to just chime in and say, if you have some funny stuff happening when you run simulations, like your robot arm explodes into a million pieces or flies through the air, that sort of thing, there's a really good chance that you have a convex hull mesh and you have self collisions on. And so what happens is if you have these convex hull meshes for parts like this and self collisions are on, then at the first frame you're going to have very deep collisions within the robot, and it's going to try to resolve those collisions with high velocities. And so you'll have like exploding robot or
It's a fun time.
solver.
It's a fun time.
And so I think that the first two things. Oh, the Gus bus has arrived.
God. Oh no.
The Gus bus has arrived.
Oh God.
Gus is an awesome guy to work with. And yes, Gus is awesome. I love
I
working
can't. I thank.
All aboard.
Thanks.
all aboard. That's right.
We have a quick question actually regarding the GPU. What are you using right now, Muammer? Just out of curiosity.
Oh yeah.
Yeah, I just activated it on the top right. If you go to type display and device memory, you can see I'm using the RTX 3090.
That's the same one that I use. It's very reliable. I love the 3090.
Actually, we have an important little question here. I just want to address real quick. Can we run Isaac Sim 4.5 on an Ubuntu 24 with an RTX 5090? So first of all, you want to be on Ubuntu 22.04. And second of all, we've got a little problem with 5090s right now with the RTX renderer. Is that right, Gus?
Well, I don't know enough about specifics, but Ubuntu 24 with RTX 5090, that is about as bleeding edge as you're going to get.
Yeah.
So eventually, yes, you will be able to run 4.5.
If I understand correctly, it's a minor rendering bug that the team is fixing now. Is that correct,
Yeah.
Eric?
Yeah,
that's right. So there's a rendering bug with 5090s that's going to come back. That's an Isaac that's going to be fixed in the next release of Isaac Sim. But as far as Ubuntu 2024 goes, I would say not until Ross and Jetson are on Ubuntu 24, which is, I don't know when that's going to be.
I don't know.
I think we kind of follow along with Ross too there and kind of support whatever they support. And right now that's Ubuntu 22.04. Yeah. Yeah, and you want a 30 or 40 series GPU is going to be your best bet for right now. Great questions.
Yeah, great comments and questions coming in.
And it's showing. That's great. It loaded.
Yeah, I just saved it, and I just reopened it because I had an error with my meshes. I couldn't see them anymore. But yeah, as we can see, I hope we can see it here. That yeah, this one is way more accurate, and this one will also work way better to pick up a cube.
Have you tried the SDF mesh?
No, actually, I haven't.
SDF signed
That's
distance
actually my
function.
favorite of the higher. Yeah, it's just a little more accurate than the convex decomposition.
Thank you.
Yeah,
I'll try this one.
if you see the really awesome videos with like tons of objects colliding, that's usually SDF mesh.
We have a question here from a viewer. I would like to know how to create two articulation route, one for robot, one for gripper separately.
You want the robot assembler, and the issue here is that you can't. You want to put an end effector on a robot arm and have it do the thing, right? I think the issue here is that if you have a single articulation route, then the second articulation route is in this same tree, and it doesn't like that. We have a tool under the tools menu on the top for robotics called the robot assembler that takes this articulation and then modifies the setup so that it has only one articulation route with the gripper articulation in place. I think there is a different way of handling if you want to control just the articulation for the gripper, like if you're talking about like a hand that has a lot of different parts to it. I don't know if that's supported natively yet. So yeah, so you can't have two articulation routes in the same chain right now as it stands, but there are workarounds, is the TLDR.
Okay, great. And I want to keep a close eye on the clock too. So we're about 15 minutes away from the typical stop. We could definitely go over, pending everybody's here at availability and the viewers' interest in continue watching. But remember, just let me know if you want to, hold off on any questions in the chat so you can proceed nicely.
Yeah, I can maybe try to show the Isaac Lab part right now, and then after, I guess we can have some questions again.
Cool. Now, while he's doing that, Eric or Gus, do you want to kind of just explain really quick the difference, people who might be joining late or not familiar? Isaac Sim, Isaac Lab.
Sure. Sure. Isaac Sim is it's the simulation itself. It's the thing that runs all of the physics and the rendering. It runs all of the interfaces for the GUI that you might want to have. Isaac Lab is sort of a layer that sits on top of Isaac Sim, and it provides all of the API that's necessary for copying environments many, many times in the simulation in an efficient manner. I refer to this as vectorization. The back end is often referred to internally as the tensor API, which is the thing that takes all of the data for all these many simulations and then packages them into nice tensors that can be manipulated on the GPU. So yeah, that's the big difference between the sim and lab. Yeah.
Thank you. Okay, people are voting for us to not stop this stream. We have hundreds and hundreds of people watching right now. It's so exciting to have all these great viewers here, and thanks for all the great questions and comments throughout. I see a lot of people answering their own questions here or other people's questions, so thank you for that. That's awesome.
I got a great comment. I just want to, or question that
Yeah.
I want to pop up real quick. How much time does it normally take to train a model?
Oh my God, America asked this whole. America wants to know. The whole country.
And I would say, so I've been training like something pretty simple, like picking up a cube. It's not that you could probably do that in just maybe 10 minutes on to get that trained. 10 or 15 minutes. Is that how long it takes for yours to train, Lychee?
Yeah, I think from the successful runs, it was 5 to 10 minutes actually to pick up the cube.
If you want to train the motion policy for a quadruped, let's say, that's a lot more complex, and that will take a few hours. But to me, that's that's surprisingly how quick.
As a rule of thumb, there are three primary factors that determine how long it'll take to train a reinforcement learning task. The first and most important factor is the size, that is the dimensionality of the action and observation space, right? The bigger those spaces are, the more that you have to explore that space in order to sample it enough to get a model of what to do in the future.
Makes sense.
So you want to minimize those two first. That's step one. The next biggest thing that's going to determine how quickly a model trains is going to be the size of the model itself, the number of free parameters that you have. And that's entirely dependent on, like, are you doing convolution? Are you doing a transformer? Are you doing MLPs? But as a rule of thumb, if you want it to be faster, you want that to be as small as possible as well. And then the final thing that determines RL training time is task complexity, right? If the task consists of many sequential long horizon planning kind of decisions that need to be made, then you have to sample that additional dimension, the time dimension, in a much finer detail in order to train that task. Whereas if the task is a very simple locomotion, walk in this direction, pick up the cube, one thing at a time, then it's much faster to train. So complexity, if you reduce task complexity, you also reduce training time. So if a rule of thumb, observation, action, space, dimensionality, model size, task complexity. If you reduce the smaller you can make all of those things, the faster your training will be.
Well, and I just want to jump in and say, if you have like a long horizon task or very complex task, it's typically beneficial to have some sort of a traditional planner.
Yes.
You don't just train one neural network that does this. That we're not going for artificial general intelligence here. Most of us, we just want to get a robot to complete tasks for us, and so it's okay to have a more traditional programmed planner with logic, and then just give small tasks to the robot and have it be able to do a variety of really simple tasks, like go to a waypoint that's nearby, but then have a planner that gives it a series of waypoints to follow, right?
One of these days, if we do just a stream about talking about whatever, I'd love to talk about the cerebellum and what we think the cerebellum does and how it works.
And then we had a lot of great comments. Okay, depends on the GPU. Yeah, it definitely does. But I've been finding, like, I can train a remote control car to drive through a series of waypoints while avoiding cones in less than 10 minutes. And I have fairly powerful GPUs on my computer. But if I look at how much of the resources I'm using, it's like not very much. And so I think that there's like a lot you can do with any GPU that's capable of running Isaac Sim and Isaac Lab, even 30 series. You can do a lot now. But if you want to do a humanoid, yeah, you're going to need something. If you want to do some general task on a humanoid, yeah, you're going to need to buy something very powerful. If you want to do something with this gripper, no, buy yourself I think 3080 or up would do it. And that's 2 generations old at this point and quite affordable. So anyway.
Fantastic. Okay, cool. So remember, I think you have another screen you want to share, right?
Yeah.
Okay, cool. Let me put this on the screen. Here you go.
Okay, so yeah, right
Oh,
now I'm inside
You should
Cursor.
post his YouTube channel again too, Edmer, in the
Oh,
chat.
yes, we can do that.
Thanks. So yeah, right now I'm inside Cursor, which is technically VS Code, or it's kind of operating on top of VS
I
Code.
love Cursor. Cursor is magic.
Yeah, it's very, very good for a lot of things. But right now in here, I have set up an external project for Isaac Lab. This one is allowing me to share my project also with the community. And Edmar, if you can maybe post the link of the GitHub
Yep.
for anyone that wants to.
Here's the GitHub. Right. There you go.
Because I don't think I will have enough time to explain everything in here. But yeah, on the GitHub, you can explore it yourself. I've already managed to have a lot of collaborators, and I'm still looking for more. So if anyone is interested, please contact me. But yeah, I wanted to mention that the USD file, first of all, sorry to have so many. I've tested it a lot of times. The one that I just created in Isaac Sim is saved here. So the whole stage, so basically the robot and everything is inside here and is being referenced from inside Isaac Lab. And in here I have 3 files that are important. Please ignore also some tests, but the ones that are important right now is the configuration of the robot and the articulations, basically. So here we have the articulation CFG, which is setting up a lot of parameters, like the joint positions, like how it should start, a lot of internal parameters, and the actuators. These settings are not optimized yet because I'm still working on it. And but like Gus has mentioned before, domain randomization will be probably also key to make it work from the sim to real. So I guess these don't have to be perfect.
Close is good.
Yeah, I'll try my best. And yes, next up, we also have another file. Sorry for that. In here, where we define the Markov decision processes, which are quite common in reinforcement learning. First of all, we are going to import a table, the plane, and some light. And afterwards, we have some MDP settings that I just go over very quick. So we have a command that is giving the object pose. But this one actually is randomizing the cube, so the object, which I didn't use yet to make it more simple. We have 2 actions. The one action is for 4 of the joints, which have the differential inverse kinematics action. And for the gripper, we have a binary joint position action. So meaning that the gripper will just open and close and just has 2 positions, basically. These will be the outputs from the neural network, and the observations are the inputs for the neural network. In here, we have, for example, the joint position, the joint velocity, the object, the distance to the gripper, or the end effector from the gripper to the object, and then the last actions that are taken from the output. We also have some other settings, and especially also for the reward. This is quite important. Which rewards I've taken is basically the rewards are kind of cheated, because in the real world you wouldn't really know where the cube is, and we will see that in a moment. But I guess I will have to replace these with cameras and pose estimation, etc., or have some sensors that manage to do this. And we just have 2 rewards that define go to the object and then lift it. And these 2, action and joint velocity, are just to make the robot a bit more smooth, because we will see in the very beginning the robot is behaving a bit too fast. Yeah, we have some terminations and a curriculum, which is just saying, okay, after a certain amount of steps or a certain amount of time, increase the action and the joint velocity to make it even more smooth. Typically after it has already learned to pick up the cube. But these have to be, of course, fine-tuned. And the last file, because before I'm showing the training, would be this one. This one is inheriting from the class that I've just shown, and is also setting some additional parameters. For example, for the binary joint position that we saw before, or the initial states, and some markers that you will also see in a second on the screen. So without going too much into detail, I will start the training. So right now I'm executing a command to train using the SKRL reinforcement learning library. And we specify the task. This is a gymnasium registry. And then I'm choosing the number of environments. I'm just choosing 32 because I'm afraid my...
I was going to say, that's not very many.
We want to bake robots, not eggs.
Yeah.
How many environments do you usually use when you train this thing?
Yeah, usually I'm training in headless mode, meaning I'm not loading the simulation on screen. Oh, I guess I have to share my screen. 1 second. Yeah, usually I use the headless mode, which allows me to have more environments because I'm not loading the...
No rendering.
Rendering, exactly. And there I usually use 4096 environments, and it's... Yeah.
Oh, wow.
There you go. And just so y'all know, this is a baby manipulator. It doesn't know anything. Its brain is completely undeveloped. And so at this point, it's just taking random actions, but then it gets rewarded based on what Muammer said, as far as probably getting closer to the cube, I would guess, or he's got some rewards in there.
Well, that is, I would love to talk about that. Like, what did you figure out for your reward function for this?
Yeah.
Or where are you starting with your reward function? Because this is a process that's ongoing. So what's your initial reward so far?
Right now in the simulation, or what exactly is meant? I'm confused.
Oh, sorry. The function itself. Like, how did you how do you determine what the reward should be? Like, is it distance to the cube, orientation of the cube?
Yeah, I just stopped it to kind of showcase this. So, yeah, the observation, for example, or the reward, sorry, is the distance to the cube. So basically, I put a marker for us to see the end effector. So basically, this marker here should be in the middle of the cube. So I'm saying, in order for that to happen, this gripper has to be open. And once it's basically in the middle of the cube with this end effector, then it's randomly realizing that it can also close the gripper. And once it's doing that, it will do some random actions to randomly lift the cube. And this one will be also a reward of the cube being lifted. And this one is a very high reward, so it's basically learning to lift the cube. And it's doing that by exploration versus exploitation.
That's really interesting because, I'm tempted to give it as an observation, give it the next step and kind of break it down to steps for it. First give it a reward for getting into position, and then give it a reward for closing, and then switch modes and give it a reward for lifting it. But you're kind of giving it all kind of that one composite reward, and it's figuring out how to plan it. It's doing the planning by itself, which blows my mind that, with some simple rewards, you're teaching this robot to plan ahead.
Well, so that's an interesting thing to talk about, though, is like, what do we mean? Like, what are we really training here, and is it really planning, right? Like the policy is a mapping from the state space to the actions of the robot, right? So we can imagine at every possible 3D coordinate that we have a function that tells us a vector, like of what direction the robot end effector should move in, right?
Yeah.
The policy is in part what defines that vector field, but there are additional dimensions because it's not determined explicitly by 3D position in space, but rather the combination of values of all the joints of the robot, right?
Sure.
So
Yeah,
it's
but
like
I
it's
think it
learning.
knows
It's like
that
learning this
if
like flow
the
manifold
gripper's
that
not around
changes
the
depending
cube,
on state.
it kind of learns if it's in a
Yeah.
state where the gripper is not next to the cube, it's got to move to
Yeah.
the cube. It's got to be open.
But
But then once in that state where it's around the cube, then it knows that the gripper should be closed, and it should be lifting it up. You know?
I hesitate to say that it's planning, right? I hesitate to say that it's like making a sequence of decisions so much as it is learning that exactly what you said. If I'm in this state, I have to do this thing. If I'm in this state, I have to do that thing. Yeah.
Well, and I guess in my mind, I can see why you don't want to just call it straight up planning, but in my mind, it's a very simplistic form of planning. You know?
It's figuring out a like whole plan. Maybe, I guess you could phrase it.
It does
planning,
different
I
things
guess.
depending on the
It's
state.
not like,
But that's the whole point of the Markov decision process. Is these robots can learn to do different things depending on the state. It's not really decision making, right? Like if you had
I'm
cubes,
being pedantic.
it's all right. It's all right. Yeah.
Oh wow, it's really going for it. Look at that! Wow.
Yeah, it's figured it out, isn't it?
So if you
With
run
only
this
32 environments too.
Yes. So if you run this headless, what's your final product look like with this current reward function?
Yeah, can you run us a replay?
Yeah, I can try to find. I'll just have to look for a second.
Question from LinkedIn user. How would we train the reward to orient the gripper to the cube? Well, he's kind of doing that he's just rewarding it for getting closer to the cube. But you can also look at the orientation of the cube compared to the orientation of the gripper and reward it or penalize it depending on how close those orientations are. So you can reward it for being closer in position, but you can also reward it for being closer in orientation.
You could calculate the upward face of the cube because you can assume that it's not going to be on some kind of like cocked edge or corner. So there's always going to be a top surface. That gives you a position for the normal vector, which is always going to be vertical. And if you want to align to pick up the cube, for example, vertically, then you would calculate the vector that points from the center of the end effector to the end of the tip of the end effector, and you'd calculate like the inner product between the up direction and this orientation vector and reward when that inner product is close to 1, right? Or reward based on how close the inner product is to 1. That would train an orientation component, right?
Keeping in, well, and there's some details. Let's just say there's some details there.
Tons
Tons of little.
Yes, there's always we could have a whole session on just reward tuning if you wanted to.
But
essentially
that's what you do.
Yeah. And you watch out for degeneracy.
Oh yeah, and there's so many little details, but yeah.
So many great comments and questions still flooding in. Obviously, I've been putting some on the screen about people's really just dropping jaws over what they just saw. Very cool, Muammer. And a couple people asking how to get in touch with you. So the best way, actually, just type in his name in LinkedIn and you'll get his LinkedIn page. I posted the link in the chat, but if you're watching this afterwards, just look for Muammer on LinkedIn and you'll find him. You will also find him, as I said earlier, on our Discord server for Omniverse. I'll post a link that will bring you right to the live stream section of our Discord server. So we have a chat. We have an area for where we post the live stream episodes, and then you could chat about that specific episode in that thread.
I think you also have a Patreon now, don't you?
Oh yeah.
Let me see if I can. Let me post that. That's a great call.
Yeah, and as you're posting that, somebody shared the link to this. This is that same manipulator on a small open source mobile base.
Oh wow, cool! It's got like the Kaya mobile base with the Omni wheels.
Yeah, so I think I don't know how much it would cost to put one of these together, but that's kind of an interesting way to, honestly, if you combine mobility and manipulation, you can do a lot there's a lot of tasks you could do.
Lychee, that sounds like that's a great idea.
Yeah.
Okay, found it. That I posted your Patreon link. So anyone who wants to support Muammer, I highly recommend it. I just put the link in there. I'll put it on the screen also if you're watching. Pretty easy. Just look for LycheeAI. It'll come up pretty soon. That's his nickname. And so you were telling me this nickname The origin story is that you just don't. You say it in your own words.
Yeah, it's very simple. I just love eating lychees or lychees. So
Sometimes it's just that simple, which is amazing.
Or is it a fairy?
Very cool. Very nice work. Awesome work here. Shane Reeks also commenting from the team. Shane is a great member of the Omniverse team, working on tutorials and documentation and a learning path. He'll definitely be on a future episode. We can chat with him more. Great to have him here joining us. Okay, let me see. There is a, let me see, here's another post listed link. There is a LinkedIn post to Lychee from the hackathon. That was,
Cool.
I guess that was posted. Yep. Okay. So, all right, we're at 3:06. Do we have any? Is there any further questions that we want to go over? Papa Chuck, I'm not even going to put your comment on the screen. I'm so glad I'm here, and that a more novice host is not hosting today's episode. I always have to be careful. Funny, but not screen presentable.
We're getting a huge influx. I'm looking at our viewers, and we're getting a lot more viewers than usual right now. And so I'm really curious what you guys want to see, or if you have questions. I want to make sure we address anything that what people have questions about. Yeah.
Great call. And then while we're waiting for additional questions or comments, Muammer, I wanted to go over really quick. So you said earlier that you really got to this point with only really about 5 or 6 months of work focusing on robotics. And I think you mentioned a little earlier, you touched on like some of the resources that were super helpful to you. Do you want to go over that really quick for people who are watching?
Yeah, sure. I would love to. So first of all, I think I also have to say a big thanks to you, Eric, for co-hosting the study group session on Discord, because it was a huge also inspiration to work like on the projects that we cover there. For example, the leather bag, and in general, the Discord community is a really great help. But of course, for official help, I watched a lot of the DLI courses, the Deep Learning Institute courses, the documentation for ISAC Sim and ISAC Lab, and also recently the NVIDIA Omniverse OpenUSD courses. I think you guys have created an awesome playlist there that I'm watching daily. So yeah, all these things helped me a lot getting where I am right now.
That's great. I will post the learning path I posted a learning path for robotics a little bit earlier. I'm going to post the other learning path we have for OpenUSD right now. It's basically free self-paced courses on OpenUSD and robotics. This one I'm pasting right now is specific on OpenUSD. And we encourage you to actually be involved on our Discord server. That's one of the best places to engage with folks like the people on this live stream, as well as all the people in the chat. We welcome you to come on. We have a dedicated channel for live stream topics, but there's also a channel in ISAC Sim, ISAC Lab. We have a channel for the various study groups. If your native language is Arabic or Portuguese, we have a channel specific to those users, so you can engage with other users in your own native tongue. And many of the channels have extensive resources pinned, so you can actually go to the Omniverse Discord server. I'll put the link for the main Discord server on the screen. As I always have to remind marketing team, look away right now while I show this banner. This is the Discord URL for NVIDIA Omniverse. There it is. You just go to discord.gg/NVIDIA Omniverse. I'll bring you right to the Omniverse Discord server. There are some great channels there. First, if you're new to the Discord server, I highly encourage you use the Introduce Yourself channel to introduce yourself. Let everybody know kind of your background, what you focus on. That's a great way to let people know how they can help. We also have events that are on the top left, including live streams, where you'll see what's coming up. And then we have a Show Your Work channel, which is exactly that. Show your ongoing work, whether it's finished or in progress, get feedback. That's a great place to learn about what other people are doing. A lot of companies actually are looking at various posts on Discord. I've heard this many times. So if you're a developer looking to be seen, or maybe you want to get work with a company, companies are actually lurking on the Omniverse Discord server. I don't like that word really, but they're hanging out, but just not posting. So that's a great place to be seen. Share your work on there. There's also a job channel on there for people who are either posting that they have opportunities or people who are looking for opportunities. And of course, as I mentioned, we have channels for all the various topics, including study groups. So there's a study group happening today, I believe, right, Eric? In 20 minutes from now, I think.
20 minutes.
Yeah, 20 minutes on the Isaac Sim and Isaac Lab topic, which is what we're talking about now. So wow, we have well over 1,200 people watching this right now live. So if you're watching this right now, jump over to the Discord server for Omniverse, and you could go to the study groups area. There's an Isaac Sim and Isaac Lab study group channel there. If you have a problem finding anything, just ping me on LinkedIn. You can get to my LinkedIn page by going to edmar.net. That'll bring you right to LinkedIn, so shoot me a message, or you can hit me up on Discord with Ed Mendy, and I will help you with anything you need to do, find on the Discord server. For those also, this is super relevant. Next week, there's a great conference happening in Boston, and I saw one of the viewers there is going to be attending. I'll be good there too. It's the Robotics Summit. If you go to roboticssummit.com, you can learn all about it if you're in the Boston area. There's an expo pass, which is super affordable. If you want to meet me there, let me know. I'll be happy to meet. It would be a pleasure. But it should be a great show and tell. I'm planning to actually host next week's live stream, which is going to feature Accenture from Robotics Summit. So we'll see how that goes. But it should be a lot of fun. Okay, let's see. We have, oh my gosh, I look away for 1 second, a bunch of new comments. Okay, so what do you guys want to tackle here?
Oh gosh, we're getting so many questions right now.
I saw some questions about the post training that I can show.
I'm going to show this one real quick. I thought this was really interesting.
Okay, I'm sharing your screen, Muammer.
If it was other than a cube, like how would you do that? So basically, basically you can tell the robot, you can reward it for lining up or going to whatever you want. It doesn't have to be the center of mass of.
Wow.
Whoa! Just a second.
That's fantastic.
That is amazing.
Holy cow.
I just want to quickly mention maybe that is after 5 minutes.
5 minutes?
Wow.
I think this is 6,000.
That is so cool.
Fantastic. Fantastic work.
That's, oh my gosh.
Now we need to get it to put the end effector. We need a policy where if we give the end effector a pose, so an XYZ coordinate and an orientation, we need a policy that will navigate the end effector to that pose. Because then we can do leader follower, right? We can do that exact teleoperation goal. Yeah.
Or I was going to say you get rewarded for getting the cube to some other location, so then you have a pick and place.
Yes, you could train a task. You could do that.
Yeah. Interesting. That's so cool.
The curriculum is key for sure. I think for this kind of task, having it change depending on the state. Yeah.
I love it.
It's
so fun because I haven't worked with manipulators myself yet much at all. I've mostly been working with the autonomous, the mobile vehicles, and so it's fun to see a manipulator go with reinforcement learning. So cool.
Okay, I got a question here in the chat from actually a developer that I've been chatting with on LinkedIn. So I'm so glad you're watching here, Farah. So she's asking how to join the study group. And great Discord's amazing. However, Discord UI is not the most intuitive. I think they're afraid to change anything because there's so many people on it already. They don't want to confuse people. But whatever the reason is, Discord UI is definitely a little confusing, I think, especially if you're just using it for the first time. So the way our server is broken up, if you go to discord.gg/NVIDIA Omniverse, you'll see a bunch of channels on the left-hand side. And then if you scroll down on the left, you'll see some of the channels are broken into categories. We have a category specifically for study groups. So it's more towards the bottom there, but you'll see study groups as a category. Then you'll see OpenUSD, OpenUSD Arabic, and then you'll see Isaac Sim, Isaac Lab. And that is where the Isaac Sim, Isaac Lab study group discussion and weekly meetings happen. So if you go to that channel, what's going to happen is that there'll be a discussion of, of what's going to be happening. And then I think they go into the community room, right? Eric, you go into the community room?
Yeah.
Yeah. So there's on the left side. So use that channel in Discord to talk about it. And then when the study group actually happens, when it's live and everyone's meeting, which is going to happen in 15 minutes, you go to the community room, which is on the left side. And the community room is a channel has a little icon next to it with a speaker, so you know it's a voice channel. And you just go in there, and that's a channel that lets people actually, instead of typing, you can actually also type there, but it's more meant for voice. So you can unmute your microphone, you could show your webcam if you like, or you can use a little text feature that's in there also. And that's basically a Hangout, not unlike the one we have right now that you're watching. So highly encourage it. Eric will be there.
I think the difference is you can talk back to us.
Yes.
And we can see your screen if you've got something, a question or something to share.
Yes.
Right. Yeah.
So that
is similar.
Yeah. So that's how you do it. Let me know if you have problems, Farron. I'll be glad to help you. Just ping me on LinkedIn. Okay, great. So this has been amazing. I want to make sure there's nothing else that we forgot to cover, right? That we talked about. We were going to try to hit. Well, actually, yeah. There's one thing.
I just want to say. Can I say one thing?
Yes, of course.
Just that in all the videos that I see on YouTube with robots that are trained, they take like hours and hours and hours of training, and there's people with like a PhD in reinforcement learning. And what you've seen here today is a sample developed by someone who does not have a PhD in robotics. Or do you?
No, definitely not.
Does not have a PhD in robotics, and he learned how to do this in a few months, and he trained it. He can train this in like 15 minutes. It blows my mind. Like,
absolutely incredible work.
This stuff used to be just absolutely for the elite, and it's just not anymore. If you're interested, then you can learn to do this, and you can do it on an affordable workstation at your house. And
the barrier to entry for robotics has been lowered so dramatically over the past year, even several months. We saw it all. For people who were following or got lucky enough to attend GTC 2025, robotics was everywhere in such a big step forward from last year. And I'm super excited to see what's happening now. A few months later, at the only a couple of months later at the robotics summit next week. Yeah. That's gonna be super exciting. So I'll be sure to share some what I find there on our Discord server. But Muammer, tell me a little bit about so what's coming next for you? You have this great YouTube channel, LycheeAI. You have this hub, LycheeAI Hub, which is basically collecting community resources. What are you working on next?
Yeah, thank you. So right now I'm working on the project right now, for the SO100, with everyone that is collaborating. I plan to invite also a lot of people for other projects and to cover these. For example, I have already planned to collaborate with a startup that is working for humanoids. Also an individual, very awesome guy that is working for quadrupeds. And I want to cover them in interviews on YouTube to show the people what's possible with ISAC and ISAC Lab. And yeah, you can expect many more videos for projects. And also if you guys have any ideas for projects or want to collaborate, please feel free to contact me. You will find everything on YouTube and the LycheeAI Hub that I created. And yeah, it's awesome. And maybe if I have one more second, I want to thank everyone for the support under the channels. It's very motivating, and especially the ones on Patreon, because I'm providing everything for free, and the help that I'm getting there and the support really helps me to continue doing this. And I would love to continue doing what I'm doing right now.
That's amazing. Well, I know you're going to have one new subscriber right after this live stream. That's going to be me. So I'll go to YouTube right after this. I think that's amazing. I have some links for resources for the community. So QR codes, obviously, for events. That goes to our Ed event calendar where our live streams and other cool Omniverse OpenUSD related events are happening in the world that are available to people remotely. And our forums, obviously, great place for official support so that they can be tracked with our ticketing system. The Discord, which we've been talking about throughout this live stream, but it's for user-to-user support. We will have NVIDIA developers like Gus and Eric who are on there helping people, but I would not consider that the place to go to if you need official support. They go on there in their spare time and try to get involved in conversation. But official support, please take that to the forums or leverage other users for their support on the Discord server. And then if you want to meet other ambassadors like Muammer, you can come to our webpage where we just announced our latest ambassadors. And depending on what your industry is, you may find an ambassador that's a great fit that maybe you can get in touch with them about their expertise, or if you want to look at some of their past work to inspire or help your team. we've heard from a lot of different companies that they've been able to leverage these live streams that we do to train their employees. So let me know if you are doing that. Let us know what kind of topics you would love for us to cover on upcoming live streams. We are very excited about the calendar for the next couple months, and we'll be putting those up on the event calendar, which is the event QR code you see there, as soon as they're finalized. But like I said earlier, next week we have Accenture coming, so really happy for that. But in the here and now, I'm very happy and just really honored that Muammer, you were able to put this together and just wow a bunch of people, including us, on this work. Really fantastic. Really, congratulations to you. Kudos for your inspiring work, and keep going. Let us know how we could help. Gus and StrainFlow, as always, I'm very, very happy that you're able to join these conversations. You offer so much information and value to
Always a pleasure.
So
Yeah, Edmar, you're so fun to work with you.
It's a good time.
Yeah.
Listen, we have a great team, and the team includes everyone out there watching. You're part of the team too. So thank you for joining us today. It's been a lot of fun. There's an ambassador here, another ambassador, Scott Dempsey. Also very, very familiar with Isaac Sim and Isaac Lab, who's a key part of the USD study group. Isaac Sim and Isaac Lab study group. He actually started it, so I'm sure you'll catch him in about 8 minutes as that starts. But thank you. Everyone has been really great to have you here joining the conversation. Any last kind of parting words for anybody that might have missed? Seems like we covered a lot of bases here.
No, this has been such. I'm just thinking about seeing that manipulator pick up that cube.
Great. Oh, actually,
I just love it. I love it.
So Muammer, if we were going to do part 2 on this, it would pick up there, right? And then I guess applying that to the assembly.
The real robot, maybe trying to transfer that to the real.
That would be a cool project.
That would be so cool.
I think that's my next goal, and I'll try to make it work as fast as possible.
Well, when you are ready, you have an open invite to come here. We'll do part 2 on this,
Yes,
and I hope everyone out there watching will join us then as well.
Yeah.
Thank you, everybody. For those who are going to come to study group in a few minutes on Isaac Sim, Isaac Lab, we'll see you on Discord server. Everyone else, we'll see you on the forums. We'll see you on Discord. We'll see you at the Robotics Summit. We'll see you wherever you are, and have a great rest of the week.
Cool.
Thank you so much.
Thank you all. Bye.
Bye.
Bye.